Hey crew, welcome back to geometry. It's been a couple days off from seeing you guys, but we're going to pick up right where we left off, and we're in the middle of two-dimensional measurement called area. These are the notes for the day. I put a blank version and a filled out version in your folder for the day, but this is basically what we're going to be talking about today. Objective for the day is to be able to find areas of circles and sectors. So again, it's just a continuation of finding this two-dimensional space, or the amount of squares that fit inside these shapes. And the shapes we've looked at thus far, first one we started off with was parallelograms. So remember, parallelograms was simple. It was just the base times the height, where the base and height had to be perpendicular. So over here I have a whole bunch of measurements on this thing. The sides here are 8, these opposite sides are 12. I need base times height here, so I need something perpendicular. So I look for something perpendicular and I see this right angle right there. That's indicating that this 10 right here is the height. So that is the height. Roll that in again, better. Something like that. So that's my height, which means it's perpendicular to this, which is the base. Well, that base is going to be the same as this over here, 8. So this is going to turn into base 8. And then height 10. So that's an area of 80 square units. So you guys did that pretty well. I've seen the work that you turned in. It looks pretty good. Then we also looked at triangles, and we said that they're just half of a parallelogram. So the formula we're going to use for them is 1/2 the base times the height, where again base and height need to be perpendicular to one another. So over here again, I need to find the base and height that are perpendicular, and I see this right angle right here. That means that this 6 is the height. The base that is perpendicular to is this side over here, which is 10. So this would be 1/2 that base, which is 10. Times the height, which is 6. So the next shape we looked at was a trapezoid. That had a big long formula. Formula was what? 1/2 the height times base 1 times base 2. And again, the base and the height still needed to be perpendicular to each other. So B1 plus B2. So again, I'm going to look for the perpendicular. I see it right here. Because that's perpendicular, that makes 6 the height of this trapezoid. So it's kind of a trapezoid turned on its side. The bases are the 5 and the 8. So if I plug this all into the formula here, the height is going to be that 6. And then the two bases are 5 and 8. So then on my calculator, what, 8 plus 5 is what, 13? So I would do 0.5 times 6 times 13 on my calculator. 0.5 times 6 times 13. And that works out to be 39. So this is 39 square units. Oh, I never finished the one up here. I just plugged in the numbers and then didn't do the math. That's 39 square units. Up here, this would be what, 60, and if I take half of that, that's 30. So the answer to this one's 30 square units. Sorry, I didn't finish that one. So then down here, this is the next thing we looked at, was kites and rhombi. We mentioned them at the same time because they have the same formula. The formula uses diagonals. So it was what, 1/2 D1 times D2. So over here I have a picture of a kite. You got to remember that this short diagonal here is bisected by the long one, so if this 1/2 of it is 4, the other part is also going to have to be 4. So now when I go to use the formula, I would do 1/2. The one diagonal is 12, and then the other one's going to be 4 plus 4, or 8. So if I do 1/2 times 12, that's 6, times 8, that's 48 square units. Or you could just plug it in your calculator. 48 square units. So that's everything we've done up until this point. So the new shape we're going to add today is that of a circle. The definition of a circle, it goes like this. It's the set of all points that are equidistant from a single point. Set of all points equidistant from a single point. So what that means in regular words, that single point they're talking about, that's the center of the circle. So the single point is the center of the circle. So now it's the set of all points that are the same distance from that center point. So for instance, this dot and that dot are a certain distance. In a circle, that would equal this distance here, equal this distance here. So basically all the dots that are going to be the same distance from that center point make up the circle itself. So that's what a circle is, the set of all points equidistant from a single point. Now that distance we're talking about is this distance here. Do you guys know what that's called? That is called a radius, that distance. So you've seen that before. And then remember, if you put two radii together, you end up with this line here. That's called a diameter. And we can kind of use that. So to find the area of one of these circles that I've highlighted here in red, you have to use a formula. And to do that, you have to use this weird ratio. This ratio is this symbol right here. And that is the ratio for pi. And what pi is, that's if you take the circumference for any circle or the distance around it and divide it by its diameter, you end up with the same value regardless of the size of the circle. So pi is the ratio. Pi button on your calculator, I'll clear this out. You can see it up above here. So see right there. To get to that, you have to hit the second button and then press pi. So there's where pi shows up on your calculator. And you guys probably used it before. The approximation for it is 3.14. But again, you guys probably just went that far. But the number keeps going. It's irrational, which means the decimal keeps going and going and going, and no repeats happen, or it doesn't stop. But that's what pi is. It's the ratio of the circumference over the diameter of any circle. We're going to use that in our formula. So the area formula goes pi, and then you could take the radius and square it. So pi r squared, that's the formula for the area of a circle. So formula for area of circle. Is that pi r squared. All right, so let's show you how to use it. So here wants me to find the area of a circle with a radius of 12 inches. So again, I would plug that into my formula, pi r squared. They give me the radius, which makes it pretty easy. So area is equal to pi r squared. So again, I just substitute in that 12 pi, and then substitute in the square 12 and square it. So the only math really to do here is to square this 12 at the start. You have to do exponents first, and that's 144. So that's 144 pi. Now, if the instructions ask you to write an exact answer, 144 pi is an exact answer because I didn't have to do anything with the decimals. I didn't have to cut any off. I didn't have to do any rounding or anything like that. So if it ever asks for an exact answer, you leave the pi in your answer. If it ever asks for it in terms of pi, you would write it 144 pi. Sometimes it's going to want an approximation. An approximation is where you're going to have to do something with that decimal. So to do that, you go to the calculator, and you're going to type in 144 pi. Remember the pi button right here? Oops, didn't want to do that. Let's clear this out. Let's try it again. 144 pi. second pi. There we go. So again, it's going to use this irrational number and multiply it by 144 basically. And so if I give you a rounded number here, if I round it to the 10th right here, it'd be 452.4. So it depends on what the instructions want. 452.4. And again, that's square units. If I round that to the nearest 10th. So down here, number 2, find the area of a circle with a diameter of 20 centimeters. So again, I would use the same formula, pi r squared. And this one's a little bit trickier because they give me the diameter. So you got to remember the relationship between the diameter and the radius. The radius is always half the size of the diameter. So if I wanted to get the radius here and the diameter is 20, that would mean my radius has to be half of 20, which is 10. So when I put that in here, so I wouldn't put the 20 in because that's the diameter. I need to put the radius in there. And so when I do that, I end up with 100 pi. Then if I wanted to round that, I would do 100 times pi. Just like that. And I end up with 3.1 or 314.2. 314.2. Again, that's in square units. So the next problem says find the radius now. So I'm looking for the radius here that has an area of 95. So in this one, still going to use the formula, area is equal to pi r squared. But now I'm not going to know the radius, and I need to find it. What I am going to know, though, is I am going to know the area. So I'm going to replace the A with 95. So I know this. So I'm going to put 95 in there. Then I set it equal to pi r squared. So now I need to solve this for r. Well, in order to do that, I got to get everything away from the r. Well, I got this squared. I'm going to take care of that later. First thing I'm going to do is I'm going to get rid of this pi. So to get rid of that pi, it's trying to multiply itself times the r. So I'm going to get rid of it by dividing it. And I can't just do it to one side. I have to do it to both sides. So on my calculator, I'm going to have to do 95 divided by pi. And that's what r squared will equal. Then we'll take care of that squared. So let's see, 95 divided by pi. 95 divided by pi. That ends up being 30.2. So r squared is equal to 30.2. So now in order to get rid of that little squared on there, I need to square root. I'm going to square root both sides. So now I'm going to go to my calculator and do the square root of 30.2. So second square root. And then if I want to take this whole number and put it down under there, so if you want to take the previous row, that's ANS. So ANS is whatever was in the previous line. So I'm going to go second, put in ANS. That's going to take whatever was in the previous line and put it down there, and that's what I wanted. So I square root that, and I end up with just the first one here, 5.5. So r is equal to 5.5. And that's centimeters. So then lastly, problem down here, same thing, I'm kind of running out of time here though, is going to be, I know the area again is 196, and I need to look for the radius again, or once we find the diameter. So that is the area, and the area is equal to pi r squared. Oops, pi r squared. So again, the first thing I'm going to do is I'm going to divide out the pi, and then I'm going to square root both sides. So the pi's will just cancel, so I'm left with r squared is equal to 196. So when I divide by pi, it cancels the 1 on the other side. And then the square root of 196, what is that, 16? I think it's 16. What's the square root of 196? Or is it 14? I think it's 14. 14. So that's equal to 14.